The London Eye is a giant Ferris wheel situated on the banks of the River Thames. In London, the entire structure is 135 metres high and the wheel has a diameter of 120 metres. As such, it's the tallest Ferris wheel in Europe and the most popular paid tourist attraction in the UK, with over 3.5 million people visiting it each year. The wheel was constructed in sections which are floated up the Thames on barges and assembled lying flat. Once the wheel was complete, it was lifted to an upright position. At first it was raised at 2 degrees per hour until it reached 65 degrees, then left in that position for a week while engineers prepared the second phase of the lift. The total weight of steel in the eye is 1,700 tonnes. The eye has 32 sealed and air-conditioned overloidal passenger capsules attached to the external circumference of the wheel, which is rotated to keep them level with the ground as the eye is rotated. Each capsule represents one of the London boroughs. These weigh 10 tonnes and holds up to 25 people who are free to walk around inside the capsule. One revolution takes roughly 30 to 40 minutes.
But I was more interested in what could be seen from the London Eye. So once aboard, I started to look out at the sights of London as I'd never seen them before. The Houses of Parliament were less than half a mile away, on a bearing of 225 degrees from north. Buckingham Palace was on the bearing of 260 degrees, just 1 mile away. The Telecom Tower was 1.5 miles away on a bearing of 325 degrees. The Barbican was on a bearing of 45 degrees, again 1.5 miles away. And lastly, the Tower of London was about 2 miles away on the bearing of 80 degrees. As we finished our journey around the London Eye, I realised how accurate a simple bearing and distance could be to plot an exact point. It is for this reason that polar coordinates were used long before our Cartesian XY coordinates, which we use today.
So there you have it,
The London Eye
in an apple pie.
We're off to McDonald's.
Back to the studio.